Bright Tuty. Every student matters.
Hello students, welcome to your math lesson. In this lesson we are going to learn about mensuration, and in mensuration this particular lesson will cover its introduction and also we will learn about perimeters. So let us start with our today's lesson, introduction to mensuration, and by the end of this particular lesson you will be able to understand what we mean by mensuration, what is the use of mensuration, and also we will learn about perimeters of flat shapes and regular shapes. Right, so let us begin with the first question, that what is mensuration? Why are we even learning about mensuration? Okay, so it says that mensuration is the branch of mathematics which studies the measurement of the geometric figures and their parameters like length, volume, shape, surface area, lateral surface area, etc. So when you hear the word mensuration, this particular word means measurement. So wherever you are measuring anything, it comes under this particular topic of mensuration. So either you are measuring what is the length of your notebook, either you are measuring the length of a wall, or you are measuring the length of yourself, you are measuring your height. So everything is there in mensuration. It's a part of mensuration. Okay, so as it says that it's a branch of mathematics that deals with the measurement of geometric figures and the parameters, like even if you are measuring the weight, the volume, or how big or small a particular thing is, everything is covered under the mensuration part. So here are some general figures that you do observe in which we are going to study. Okay, so these are some broadly given 2D and 3D shapes to you. Moving ahead, why do we need to use and learn about this mensuration? Do we even use this mensuration in real life? So the example is yes, of course. If you are measuring your height, you are measuring your weight. If you want to measure the how much this particular area is, for which you need to do the fencing, for example. If you want to see how much water will be filled in this tank. If you want to measure the height of a building, you want to see how much distance is this particular building from this particular point. Everything is covered under mensuration. Okay. Now, let us start with the plane figures, and then we'll begin with this particular lesson where we'll start with the perimeters. Okay, because this is the basic part of mensuration, that is when you are calculating perimeters. We'll quickly get to it. So this slide says that we are going to learn about plane figures. What is a plane figure? The closed 2D shapes are referred to as plane figures. As you can see in front of you, it's just a flat shape that is shown. So anything like a square, a rectangle, a circle, or a trapezium, or any kind of a polygon that you are drawing, when it is 2D shaped, it is a plane figure, right? And here it says that this particular, see that you see the arrows all around, this is the boundary of the given figure, and D is basically the area that you see inside. Okay, point D comes in the area of the given figure. So this is the area of this particular figure. Let me just choose some color. Yeah, so everything that you see inside this particular boundary, it is the area of this particular boundary, this particular closed shape. So we will learn about area as well in this particular lesson, but we are here going to start with the topic that is very interesting, very simple to learn. It is called the perimeters. Perimeters is basically if you go round the figure along its boundary to form a closed figure, then the distance covered is the perimeter of that figure. Did you understand this line? It says if you go around the figure along its boundary. So I hope you have seen this here. Where is the boundary of this particular shape? Where you see this all, I'll just choose the other color. Hold on. Yeah. So where you see all this part, this is everything that comes in the boundary of this particular shape. So when you are going along this particular boundary, so when you are going around a figure, it is along its boundary, it is called that you are going around the perimeter of that particular figure. Okay, hence perimeter refers to the length of the boundary of the closed shape. Clear? Now, if a figure is made up of line segments, say we are looking at a particular polygon, so it is made up of only line segments, Then the perimeter we simply calculate by adding the lengths of all the sides. Very simple. Let us see. As you can see here, we are given a figure which is a rectangle and we are given the measurement of its sides. So here the longer side, this is 7 and this particular side is 3. So these are the measurements that are given to you for this particular rectangle. Okay. Moving ahead. What does it say? It says the idea of perimeter is widely used now in daily life, where if a farmer wants to fence its field, okay, fencing is like it's putting a boundary. Say it could be fencing with a metal wire, or it can be fencing with a wooden. It could be a wooden fencing. So anything that you are covering your boundary of the land that you are occupying. Okay. Then it says an engineer who plans to build a compound wall on all sides of a house. So again, you need to know what is the perimeter of that particular compound, right? Then it says a person preparing a track to conduct sports. So any sport that you see, it needs to be under a certain boundary, a certain area, right? So this is all comes under this particular concept of perimeter. And this is just a basic more ideas to see where in our daily life we deal with perimeters. It says that all these people use the idea of perimeter. Perimeter is the distance covered around the boundary, forming a closed figure when you go round the figure. Very simple to remember. Let us see some questions and then we'll understand this much better. The question says, measure and write the length of the four sides of the top of the study table. And here we are given the sides of the study table marked as A, B, B, C, C, D and D. So let us mark these sides on the table as well. So let this be A. I'll just use the smaller pen. Okay. So this is A. Say this is B, C, and this point here is D. Okay. So now let us see how we can find the measurement of all the sides of this particular table. So now, what is the length of AB that you see in the diagram? It is 1.2 meters. So how can we write 1.2 meters in centimeters? I hope you know that in 1 meter, we have got 100 centimeters. Is that right? In 1 meter, we have got 100 centimeters. So if it is given 1.2 meters, so that means how much is this? It is 120 centimeters. Clear? Now let us write it here, 120 centimeters. What is the length of BC? It is 150 centimeters, because this is 1.5 meters, so it will be 150 centimeters. Now what is the length of CD? CD is this particular length here, right? So this, I'm sure you must have seen that all the tables are in a shape of a rectangle, and rectangle shape has got the opposite sides of equal length, right? So if AB, this particular length is 1.2, so the length of CD will also be 1.2, that is 120 centimeters. Now what is the length of DA? Look here, it is opposite to the side BC, thus it measures 150 centimeters as well. Clear? Now the sum of the lengths of the four sides is basically AB plus BC plus CD plus DA. Let us write it down. 120 plus 150 plus 120 plus 150. Now let us add them all together. 150 and 150 equals 300, and 120 and 120 is 240. Adding them together gives 540. So the total perimeter of this particular shape, that is a rectangular table or a study table, 540 centimeters, right? So if we want, we can also, we can convert this into meters as well. So it will be 5.40 meters. Clear? Now, if someone asks you what is the perimeter of this particular study table, the answer will be 540 centimeters, or it's your wish, you can say 5.40 meters or 5.4 meters. Either way it's correct. Okay. Now let us see another example. Here it says measure and write the length of the four sides of the page of the notebook. So suppose this, what you see in front of you, it's a page of the notebook and we are going to find the sum of the lengths, right? So here let us again mark A, B, C and D. So if you can see that here CD is marked as 9 centimeters. So I hope we can confidently say that if CD is 9 centimeters, AD will also be 9 centimeters, right? And if BC is given as 6 centimeters, we can write the length of AD as 6 centimeters as well, right? So let us write it down here. The sum of the lengths of the four sides where AB equals 9, BC equals 6, CD equals 9 and DA equals 6 centimeters. So what is the sum of them all? So 9 plus 9 is 18 and 12. So it is 30 centimeters. So what are we doing basically? We have started from here, say point A. Then we are going all around this particular shape. And while we are just going around all its boundary, we keep on adding the particular length we travel so that we reach the back to the point A. Okay, so we are just going along the boundary and adding whatever distance we have traveled. So it says what is the perimeter of the page. So what is the perimeter? It is 30 centimeters. I hope this is clear how we have calculated the perimeter for this particular notebook. Moving ahead to the next question. It says Meera went to a park 150 meter long and 80 meters wide. She took one complete round on its boundary. What is the distance covered by her? So let us first draw this particular diagram. So it says Meera went along a park. So the park is usually rectangular in shape, and as we can see the measurements that are given here, so it definitely shows that this particular park is rectangular in shape as we are given that it is 150 meters long. 150 meters long. So the longer area that you have here, the longer length you have, this particular side we'll write as 150, and we are given the width as well. So width is here, it is 80 meters. Clear? Now it says she took one complete around the boundary. So say we are starting from this particular point. Let us name this as A, this as B, this as C and this one as D. So we are going to start from A. We'll go all along its boundary and we need to come back to A in order to see how much distance she has covered. Clear? So let us work this down. Now let us say, it says what is the distance covered by her. So we'll say distance covered by Meera is equal to AB plus BC plus CD plus DA, right? Now what is the length of AB we have? It is 150 plus 80 plus 150 plus 80, and everything that we have got is in meters. I hope you are clear why I have written 80 for BC and why I have written 150 for CD, because they are the opposite sides of a rectangle and the opposite sides of a rectangle are equal, right? So now let's add them together. 150 and 150 is 300 and 80 added to 80 is 160. So the total is 460 meters. So this is the total distance that Meera has walked in the park. I hope this is clear how we have worked this answer. Moving ahead. Well, I would like to say this particular thing here. In this lesson, we are going to do a lot of questions which are only and only based upon the perimeters of a particular shape, whichever shape we are working with, a flat shape, right? So because perimeter is just mensuration, this particular chapter is all about measurements, all about solving the problems. So all this chapter will have only and only questions, okay? And there is not much to read about the theory part in the measurements. It's just that you need more and more practice with the questions. Now comes a shape that is a very different kind of a shape. You don't know its name. So how do we name such shapes that are just a random shape? It's a polygon, right? And depending upon the sides it has got, we can name this polygon. So let us see how many sides do we have. 1, 2, 3, 4 and 5. So with 5 sides, the shape polygon is known as a pentagon. So this is a pentagon, right? Now let us find what is the perimeter of this particular shape. Now here let us again name this particular shape as A, B, C, D, E. Okay. Now let us write down perimeter is equal to AB plus BC plus CD plus DE plus EA. Now I want you to see this carefully. We start from a particular point and we must come back to that particular point after going around the whole shape along its boundary, and make sure that you don't leave any of the line segment unattended. Okay. Now let us write what is the value given to each of them. This shape that you have seen in front of you, it has got all the sides measured in inches, right? So it is 4 for AB, then 3, then 2, then 6 and then 5, and everything that we have got is in inches. Now let us add them together. It's 6 and 4 is 10, 10 and 5, 15 and 5, it is 20 inches. Clear? I'm sure it's simple, but little practice and practice and being accurate with your numbers is going to give you the right answer. Moving ahead, the next shape that comes here is again a polygon. So let us again, we can simply write down what is the perimeter this time. Perimeter is equal to, so it is 1 centimeter plus 4 centimeter plus 2 centimeter plus 5 centimeter plus 6 centimeter. Everything is in centimeters. So let us add them together. This is 10, 15, 16, 17. It is 18 centimeters. Okay. So now I hope now you're clear how we are adding all these. One thing that I want you to be careful about is that if suppose any of the side has got different units, instead of say if this is my shape and I have given this as 1 meter and this one as say 20 centimeter. Okay, so I need to work perimeter in using just single unit. Okay, I cannot use one. I cannot just find the answer as 1 plus 20 plus 1 plus 20. This is absolutely wrong. Why? Because one of the unit is meters and the other one is centimeters. So either I convert everything into meters or I need to convert everything into centimeters. Okay, so this needs to be very much clear that every time you're solving any question, make sure that all the units are same. Now let us do this question here. Let us name the sides. Okay, so it will be easy for us. So it's A, B, C, D, E, F, G, H. Okay, so we have marked all the vertices of this particular shape. Now let us find what is its perimeter. So the perimeter is equal to AB plus BC plus CD plus DE plus EF plus FG plus GH plus HA. So we started from A and we ended to A. Now let us put the values of all these. So everything that we have here is in meters, right? Now very important thing is going to come very soon. The length of AB is given as 7 centimeters. So let us write 7. The length of BC is equal to the length of AH. Is that right? AH and BC, they are equal in length. So let us put plus 5. What is the length of CD? It is 1 centimeter. What is the length of, we are done with CD. Then we have, oh, see, I have written CE here. It's wrong. It's DE. So it's DE, then EF, FG, GH. Okay, then it's fine. So now what is the length of DE? DE is given as 4 meters. Now what is the length of EF? We don't know what is the length of EF. Let us find out what is the length of EF. Look at this particular length AB. What is the length of AB? It is 7 centimeters. Clear? Out of this 7 centimeter, look here, we have got GH, right? It is 3 meters. So if you see, it is somewhat here, 3 meters. If we try to overlap this side, GH with AB, it will be somewhere till here. This much will be the length. Yeah. So this much will be the length of HG. Now what is the length we are also given here on the side is CD, this much. So this small part of this complete length till here, it is 1 meters. So we know this much part, it is 3. We know this much part, it is 1. And we know the complete length here is 7. So can you tell me what is the length of EF? That is this particular part that we have not got here. What do you think is the length of this particular part? Out of 7, take away 3 and take away 1. Whatever you are left with, it is the value of this particular shaded part in blue. Okay. So 7 take away 3, take away 1. Let us write down the value. It is 3 meters. Why? Because 7 take away 4 is 3. Clear? Now moving ahead, we are done with EF. Now it is FG. Again, we are going to find what is the side FG. So look what is the corresponding length that we know with FG. We know that here AH, this is 5 meters, right? And out of this 5 meters, okay, great. We have got this particular side, right? We have got this particular side ED. It equals to the measure. Okay, we don't even need to have to calculate anything. FG, this particular side here, it is equal to ED, right? So let us write for FG 4 here as well. Now, the next one we have got is GH, that is 3 meters. Then we have got HA, that is 5 meters. So everything, see, I'm putting everything in brackets and I'm writing meters again. So either you write 7 meters plus 5 meters plus 1 meters plus 4 meters. So writing meters either with each and every number, or you can just put all the numbers in a bracket and put meters at once outside the bracket. Okay. Now what is the answer to this? We need to add all these numbers. Okay, so let us add all these numbers. So I'll just cross off the numbers when I add them. So 7 plus 3 is 10. 5 and 5 is 10 again, so it's 20, 25, 29, 30, 31, 32. So the answer is 32 meters. Now we don't need a bracket, it's just a single number. So the answer that we have calculated is 32 meters. So I hope this part is clear, that if you are not given the length of a particular side, how you can look at the corresponding sides that are given to us and how we can get to the answer of the unknown side using those known sides, right? Now look at this particular question here. Here you are going to use these blocks that you see in each of the images. Assume that each of these blocks measure 1 centimeter each. Okay, so say this particular small box, okay, say this particular box I'm drawing here, this box measures 1 centimeter, 1 centimeter. Okay, so it is 1 centimeter, 1 centimeter, the square of 1 centimeter. Okay, clear? Now we are going to use this particular square to find the area of this particular shape. It's very easy to calculate when you are given such a shape. How? You just need to count the number of squares that are given in a particular shape. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the answer to this is, let's just go back. Okay, we were calculating. We know that each side of this particular box is 1 centimeters, right? So let us calculate from here. This is 1 centimeter. This is 1 centimeter again. So 1, 1, 1, 1, 1 and 1. Okay, so let us see what is the length given. So it is 1, 2, 3, 4, 5, 6. So this particular length that is given to us is 6. So we are not given any unit. We are not sure whether it's centimeter or it's meter. Here I have just assumed that maybe it's centimeter. This is just an assumption. We are not given. So what we do in such case? We write 6 units. Okay. Make sure that you do remember that if you are not given any value, that whether it's meters or it's centimeters or it's inches, in that particular case, you just write units. Okay. So now here we have got 6 units for the length. What you see in the width is 1, 2 and 3 blocks. So it is 3 units here. Right. So let us calculate. So if this is 6, then here also it is 6 units. And if this is 3, here also it is 3 units. Simple. Now what is the perimeter? It is 6 added to 6 added to 3 added to 3. So the answer is 12, 13, 14, 15, 16, 17, 18 units. I'll just erase this part from here. So the answer is 18 units. Okay. Now let us see the next one in the B part. So what is the width it is given? It is 3 units again. And what is the length? 1, 2, 3, 4, 5. So this particular length that is given to us is 5 units. So if this is 5, the opposite one will also be 5. If this is 3, the opposite will also be 3. So what is the perimeter for this particular shape? 5 plus 5 is 10. And 3 added to 3 is 6. So it's 16 units. Clear? The next one here. Now we are going to add all the sides. So this particular side is 2 units. This particular side is 1 unit. This particular side is 3 units. This particular side is 2 units. This particular side is 5 units. And this particular side is 3 units. Let us add them all together. So 2, 1, 3 and 6, 8. And then we have got 5. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16 is the answer. It is 16 units. Clear? Now the last one, D part, it's simple. We have calculated such questions already. So if this is 4 centimeters, this is 4 centimeters. If this is 6, this is also 6 centimeters, right? So 6 added to 6, we are just going around the boundary and adding all these numbers. So 6 added to 4 is 10, added to 6, 16, added to 4 is 20. So the answer is 20 centimeters. Clear? Moving ahead to the next shape here. Here we have again got a very complicated shape. So let us just let us keep on adding these numbers, and I'll highlight each of the length with a different color so that it's easy to remember what all sides we have covered. Okay. So perimeter is equal to, starting from here, this is everything clearly we can see is in meters. So no worries about the units. So it is 12 plus 3 plus 7 plus, we are not given this particular side here, right? How can we calculate? This particular complete length is given as 12 meters, out of which this much part is 3, right? And this much part is 3 again. Out of 6, small portion is 3, another small portion is 3. So 3 added to 3 is 6, and from 12 we take away 6. What is this length left here? It is 6 meters. I hope this is clear how we have calculated the unknown length. So writing 6 here, then we have got 10, then we have got a 3, then we have got a 15, and finally we have got a 12. And everything here is in meters, right? Now let us add them all together. So let us add these numbers. 12 added to 3 added to 7 is 22, and then added to 6 added to 10 is 38, added to 3 added to 15 added to 12, and the answer is 68 meters. Okay, so this is the total of all the sides of this particular given shape. Moving ahead, now we are going to learn, this is something very important that we are going to learn now. We are going to learn about the perimeters of certain shapes that are the regular shapes. Before regular shapes, we are going to learn about a rectangle, okay, which is a very common shape that we deal with. So there is something special in a rectangle. What is special is that we know its opposite sides are equal, right? A rectangle is a closed shape with two pair of equal opposite sides. So whenever you're finding the sum of a rectangle of all its sides, we write its length plus breadth plus length plus breadth. Is that right? This is how we add all the sides in a rectangle. So do you see the length? It is coming twice. And then breadth, it's also coming twice, right? So how we can write this? Instead of writing length plus length, we can write twice of length, right? Plus twice of breadth. So if we have 2 times length and 2 times breadth, what we can do? We can bring 2 as common and times it with length added to breadth. Now this is the formula that you need to remember when you are calculating the perimeter of a rectangle. Okay, so make sure that from this particular slide you are going to remember this formula, that is 2 times length plus breadth. This is how we say it, 2 times length plus breadth. This is the perimeter of a rectangle. Let us see one example, then it will be clear how we are using this formula. It says the length and breadth of a rectangular swimming pool is 16 and 12 meters respectively. So let's say this is a rectangular pool. Okay, and here we have got 16 meters, that is the length, and here we have got 12 meters, that is the width of this particular pool, right? So it's rectangular pool. So what we are going to do, we are going to use the formula of calculating the perimeter of a rectangle, right? So the formula is 2 times length plus breadth. Now here we'll just put the values of length and breadth in the formula. So we are given the length as 16 and breadth as 12. So 12 plus 16 is 28, right? So now 28 times by 2 is 56. So the answer is 56 meters. So this is how you can calculate, either doing of 16 plus 12 plus 16 plus 12. Instead of doing this part, what we have done, we add 16 and 12 and then we times it by 2. I hope this is clear how we are using the formula to calculate the perimeter of a rectangle.